Alright guys, so we're gonna start a session. I'm gonna set the context for this. This is a session on some of my important topics. So we cannot cover the entire full stack engineering domain in one go, but I'm gonna try to do as much justice as possible to it. So I'm gonna open chat GPT, right? And what we're gonna do is we're gonna go right into new chat, right? And what I'm gonna do is I'm gonna uh, start a new chat, and I am gonna say uh, suggest me what skills should I learn as a computer scientist, full stack developer in 2026. Although I already have some experience with front-end technologies, but now we're gonna raise the bar and we're gonna go into full stack. So yeah, so these are the skills. So if you want to grow as a computer scientist, the key is basically how do you build your fundamentals. So there are 6 deep skills it's talking about for uh, basically understanding computer science and then production engineering. So you should know data structures and algorithms. That is very important, and this is a very deep topic. Like, you start very easy from arrays and linked lists to stacks and queues, and then it becomes very difficult going forward. Difficulty level is higher when you go to non-linear data structures and other kind of algorithms, right? So the problem is that lots of people don't know how to solve these computation problems using data structures and algorithms, because they are not first of all, you have to get comfortable with any one programming language, and then you have to be able to articulate solutions to given problems, and you have to understand what pattern is being applied into every problem statement, and there can be multiple patterns going on in one problem statement to solve this problem statement. So rather than endlessly looking into problem statements and hoping that you would be able to crack, you should know patterns well so that you can write proper structured logic, and you can utilize any pattern in any problem, right? So as a systems engineer or a full stack engineer or a software developer, you should know these skills. Next is some important concepts of computer engineering, which is uh, what is stack, what is heap, what is caching, what is threads, concurrency, all these that are listed down here. Garbage collection is very important stuff, event loops and networking basics. So like, how does JavaScript run internally, how browsers work, how operating systems work. Then, since it is full stack web development, JavaScript development is very important. So so basically the fundamentals of JavaScript, like how to write loops and how to uh, work with JavaScript. Core JavaScript is very important. What is execution context, what is memory, what is scope, what is memory creation phase, what is functional scope, block scope, lexical scope, right? And then how does temporal dead zone work, right, for the let variable and const variable. What are the modern practices of writing JavaScript, and the older ideas like closures, async await, promises, garbage collection, micro tasks, macro tasks. These are very important. So yes, these are very important. You should know them deeply. Next is immutability patterns and performance optimization and functional programming. So these are also important. Now, front-end engineering. Front-end engineering basically means that you should be very in depth with HTML, CSS, and JavaScript, and then you should also be able to take a problem and take few hours or days to solve it with proper architecture, good performance, and good UX. So You need mastery over a lot of topics for this. One is performance, like what is bundle optimization, what is tree shaking, what is lazy loading and code splitting, and what are performance budgets, right? And what are accessibility, browser pipeline, critical rendering path, all of this stuff, right? So you should know React.js well, Next.js well, component architecture very well, state management, you should be very good at it. SSR, SSG, ISR, these are new in the frameworks. Server-side rendering, static site generation, and incremental site static regeneration. So if you know React, then you should know how its reconciliation algorithm works. How does the server components get hydrated? Like how does the uh, JavaScript attaches? How does React attaches JavaScript to the DOM, and then hydration happens? And what are the React virtual DOM and diffing strategies, rendering strategies? Now, if you also learn a bit of backend, then you're gonna have a very good chance to be able to build almost anything in this world. Any computer science system, any software system you can build. So you should know REST, you should know Graph QL, you should know how to make backward compatible APIs, and pagination and rate limiting and authentication, right? Then you can pick one stack. So Express is very good for Node.js, and then you can, if you're using Python, then you can use Django or Fast API. And in backend, you would be generally putting middlewares, you would be putting logging, you would be putting observability and security. So these are some important concepts. Then if you talk about SQL, then databases basically, then you should know SQL. You should know how to index your queries, you index your data, you how to make indexes in your tables, and then what is query optimization, and what are joins, full join, inner join, outer join, and left join, right join. uh, Transactions, how you can commit or roll back a transaction. What are serializability, conflict scheduling, what is data normalization and table normalizations, 1NF, 2NF, 3NF, BCNF. Then asset properties, atomicity, consistency, isolation, and durability. These are also very important. And if you're using some database, and if you're choosing on, if you're writing complex queries, then you should go for something like PostgreSQL or MySQL. And if you're using NoSQL, then you can use MongoDB. It's very useful. And you can use when you have no when you want very flexibility in the structure of your data, very much flexibility in the structure of your data. So you can use MongoDB, you can use Redis, you can use Elasticsearch. And eventually you would need caching, and you should know what is eventual consistency and what is distributed systems. Now system design is very important. System design is something that you should look into. So like if you have some if you have some software that you are shipping to users, right? You would be hosting it somewhere, right? And users would request data from your from the users would request their data in that software. So you should know what is load balancing, you should know what is horizontal scaling, you should know what is caching, you should know what is CDNs. But why do we use CDNs? Because if somebody, why do we use CDNs? So we use CDNs because uh, for example, a user requests something, user basically requests a page from your software on the internet, and user is sitting very far from your server. Then if the CDN is in between, then the CDN can be placed geographically closer to the user so that the latency comes down, right? So this is called like geo geolocation based CDN routing. And this is one important concept of CDNs. Now you should know about microservices. So microservices are ones which give you what do you call them? Microservices are those which have uh, basically separate responsibilities for one particular business use case or functional use case, right? And you can have one for payments, one for checkouts or carts, okay, one for catalogs, and one for your what do you say, your orders, for example, right? So you can have different microservices to manage different parts of your system, and they can be decoupled, and they can talk to each other through protocols, HTTP protocols, or like whatever. Yeah, so basically REST or GraphQL protocols. So this is how they can talk to each other. Then there is message queues. Message queues is also like you can send one event from one system to another system, and they can form a queue, and then once they reach it, it can follow a producer consumer sort of pattern, right? Then you have technologies which is Docker, Kubernetes, Nginx, Kafka, RabbitMQ. Then you should know about distributed system concepts, which is CAP theorem, consistency models, replication, sharding, and fault tolerance. So then if you want to learn DevOps and infrastructure, like if you want to be an infra engineer, which is like very important, then you should know basics of how to work with Linux, and then you should know Docker a bit. Then you should know CI/CD. Generally, we can set it up with Jenkins, and then Git workflows, and then monitoring, logging, and cloud infrastructure. So cloud, you can use AWS or Google Cloud Platform, and then you should know what is compute, what is storage, what is serverless, what is networking. Now AI assisted engineering. So basically prompt engineering based on using AI. You should be able to review the code, or you should be able to write unit tests. If you don't want, if you're being want to save time, yours and everyone's, then you can also ask AI to review your code first, and then it can understand, okay, this is the part that is having some issues, you should fix this part, right? And then you have GitHub Copilot. We are using ChatGPT right now, Cursor. Okay. So by the way, AI is a topic which is very general purpose. It can be used by lawyers, doctors, engineers, businessmen, accountants, all sorts of people, right? But if you are an engineer, then you should definitely use some AI tool in today's market, so that you have a competitive advantage over those who don't use. Okay. Now, but you cannot heavily rely on AI. What you rely on more is your thinking, which is the most important part. You should know that my system has some constraints, it is following some assumptions, and it can break under some assumptions, and it should have scalability and performance, right? And it should be maintainable, and other engineers should be able to read your code. So let's just try to become that level of engineer. So let's deep dive into so the first thing that we were doing was uh, data structures, right? Let's deep dive into data structures first, and then deep dive into rest of the things. Okay, so this is how it's gonna be. So uh, let's go layer by layer, right? One is that every time you basically face a algorithmic problem, you think of the simplest solution, the brute force solution that you have to just ship, right? And then you can think of how can I optimize the time complexity and the space complexity of my code. And then you basically look into something like pattern recognition, that what kind of pattern, data structure pattern, can I apply in thus problems. So that is one thing. So for example, this is a very simple question that we have to find the largest number in an array. So we can just iterate over, and whenever we find a candidate which is greater than maximum so far, we can update the maximum so far, and we return the maximum. So we have an input, that we have an array, and the output is the uh, maximum element of that array. So we were writing an algorithm to do that. right? Now again, this is the same thing. We should know time and space complexity. So what is time and space complexity? Like every code is running, it's running statements by statements and it's been executed, right? So it can be fast or it can be slow, and it can take some memory in the RAM, or it can take some memory on the disk. But we do not generally consider disk for actively running programs in our process schedule. So time and space complexity is something which you will, as a computer engineer, you will come around most of the time. So uh, order 1 complexity, order 1 is constant time, order log n is logarithmic time, and order n is linear, and order n log n is sorting, and then nested loops are order n square, right? So that's something which is very great. Okay, so order n square is important because you cannot have very slow algorithms for large inputs. So you can at most, I think what I think, if the input size is small, you can support up to n cube maybe. But if the input size is large, you may not be able to support more than n log n, right? So that is something. Now data structures. So the fundamental thing that we work with is an array. Array can store, so depending on the programming language, arrays can be static or dynamic, and they can support a single type or multiple types. Okay, so we can have access, so we can access the array element by index. That takes order 1 time. Then we have inserts. If we're inserting something into the array, then if we're inserting at the last, then we have to traverse to the last, and then we have to create a new space and then allocate memory for that space and then add something to that. That is order n. Delete also is order n because we have to shift the elements, right? So these are the common operations that we can have. And uh, other is we can search for something in the array, but that's a different algorithm. So if suppose this is an example problem that we have to reverse an array. So how do we implement it? So we basically take the array as an input. We say that okay, our left index is the first one and the right index is the last one, and then we swap the first index with the last index, the element at that, and we increment left by 1 and decrement right by 1. So as left meets right, our algorithm stops and the new array is the shuffled array, like the reversed array. This pattern is called two pointers because we are using a property of array that we can have elements at start or end, and then uh, sort of uh, we can sort of make that array uh, we can sort of reverse that array using two pointers by swapping individual elements. Okay, now next is hash tables. So whenever we are using databases, compilers, or objects or cache, then we are working with hash tables, right? So hash table is kind of like a dictionary. Against a key you can put a value, right? So you can insert something in order 1 time, okay, and you can search something in order 1 time, and you can delete something in order 1 time. Now suppose we want to find duplicates. So what we can do is we can define a function. We can say that this is our set, it's our hash map or hash set, and then what we can say is that whether we saw that element before, then yes we can return, otherwise we can add that to the set. So that is how our duplicate element can be found. Then we have last stacks. So this is last in first out. So we can add an element to top of the stack and remove an element from top of the stack, and we can figure out what is that element at the top of the stack, which is push, pop, and peek operations. So we can, in Python we can do dot append and dot pop. Okay, how do we maintain stacks? So the stacks, why are they used? Stacks are used in actually the memory area of the programs to hold variables and functions. and also to manage recursion and to manage browser history and undo operations. So stacks are very useful to use in the computer science problem. So if we have some expression to evaluate, we can also use stacks, right? Now there is an example problem of valid parenthesis. So suppose you have a group of text, a sequence of text which is having some parenthesis. Now you want to see if the parentheses match together, like every opening has a closing one in the exact order, in the exact sequence. Then you can use stacks to maintain that. To basically, whenever you see an open bracket, you can say that okay, this is gonna be added to stack, and when you see a closing bracket, and if it matches the top of the stack element, then you can say I can remove that, and then when at the end if your stack is empty, then you can say that my parentheses were valid, right? Now next is queues. So queues have two operations, which is adding something to the end of the queue and removing something from the start of the queue. Okay, so in Python you can use the dequeue interface, and you can use queues to manage tasks, schedule tasks, and then in messaging, in message systems, and also in breadth first search. So linked list, if you talk about linked list, then unlike arrays, elements are not stored continuously. So value, then next. So then you have self dot val equal to val, self dot next equal to none initially. That's how you define a node. Now what you can do is you can easily insert or delete something from the linked list, but the disadvantage is that you cannot access it in a constant time. Next is trees. Trees are also important. So generally you would need to understand binary tree and binary search tree, or maybe AVL trees. Uh, and one variation is red black tree, and then try is something which is important. So these variations also work. So you can have multiple traversal types: in order, pre-order, post-order, level order. So in order, if root is none, then you return, and in order, root dot left, then root value, and then you recursively call root right. So this is how basically you process the left subtree first, and then you print the current value at the root node, and then you process the right subtree. So this is how you can do in order. And similarly there are other traversals which is pre-order. In pre-order, what you do is you print the value first, and then you do pre-order to the left and then to the right. In post-order, what you do is you do the right first, and then the left, and then the value. In the post order, you do left, right, and value. In the pre-order, you do value, left, right, and in order you do left, value, right. Graphs. So if you are making social network, then you can use graphs to map those relationships. If you're using Google Maps, then also you can use graphs. And then if you're routing something from the internet, then maintaining routing tables, DNS records, and then basically forming a broadcast connection with some through socket layers, right? All of this can be done through graphs. Routing can be done through graphs. So we have adjacency list, adjacency matrix, and then we have DFS, BFS. So if you try to understand DFS, you can maintain a queue first, right? And then you can take out an element from the queue, and if the element is not in the set, then you can add that node to the visited set, and then you can also add the graph node. Now next is algorithm patterns. So instead of learning random problems, you can learn patterns, and most of the interview questions are in these patterns only. So there is 2 pointers. In this you use sorted arrays, okay, and then you can use pairs and you can use reversing. What is sorted arrays? So if your array has some integer elements or numeric elements, and then uh, if you have if you have to do some calculation in that, then you can use 2 pointers to achieve that calculation. Similarly, if you have to reverse some array, then you can use, or if you have to maintain some find a pair of something, then you can use 2 pointers. Sliding window is used when you have a continuous subarray or substring, and in that you can use a sliding window approach. Binary search is where you are searching something into the array, and then you want to read every moment you can, at every point you can make a decision whether you have to choose the left half or the right half, or like you can reduce the problem statement into two parts and then eliminate one part and take the other part. So based on that you can use binary search. That is why it is called binary, because you are basically picking up two parts of the search space and then you are eliminating one of those. So this is how it is. Then we have recursion and backtracking. So recursion is something that, okay, your software system, like your computer, would maintain whenever it's running a program. It will maintain a stack. So you can make a function call, and that function call calls itself into with a shorter version of the problem, with a sub version of a problem. Then that is a recursion space that you're working with, and then when all the recursion problems are collected, then they basically go into the final uh, uh, sort of result. Okay, and then we have backtracking. So backtracking is something that, okay, you explore a solution space, and then when you don't find your answer after going deep enough, then you look back with the closest ancestor and then try another solution space branching out from there. Okay, so in permutation, combination, sudoku and n-queens, you can use recursion and backtracking. Next is dynamic programming. So dynamic programming is a bit hard, but it's a very important concept. So uh, it's there are some standard problems like Fibonacci, knapsack, longest common subsequence that you can study to understand dynamic programming. But the idea behind dynamic programming is that I can have a state at intermediary state in my app, in my program, and I can store that computation result in an intermediary state if it can be broken down into two or more sub problems, right? And solution of those sub problems are optimal, and the optimal solutions of those sub problems combine together to give an optimal result of the base of the top level or the base level problem. So that is where you can use dynamic programming. And then we have greedy algorithms. So in the greedy algorithms you can have optimal choices, local choices, and then you can use activity selection or interval scheduling, or you can basically solve these problems using greedy algorithms. Now there are advanced DSA problems, which is segment trees, Fenwick trees, union find, topological sort, shortest path algorithms, Dijkstra's, Floyd-Warshall minimum spanning tree. So if you know DSA very well, then you can go into logical thinking and optimization and debugging and problem decomposition very easily. And using these skills, you can design any system. So that is why they are very important part of computer engineering, and they are still relevant in the tech industry, right? So the right way to learn DSA is that you do some order. You start with the basics, which is arrays, hashing, and then you go into two pointer, sliding window, then stack, then binary search, then linked list, trees, graphs, and then dynamic programming. So this is the deep dive of DSA. Now let's go back to so I think this is enough deep dive into DSA for the beginner level, right? Then you should go into uh, a bit of JavaScript after that, right? So let's let's deep dive into. We'll go with the two hottest languages in the industry right now, which is JavaScript and Python. There are others also, but let's deep dive into JavaScript. Actually, Java itself is also a very good language for enterprise level software development. But I think JavaScript and Python can solve almost all the use cases that you need to have. So you can basically go deep dive into JavaScript and Python. You can build your own servers with JavaScript using Node.js, and you can build your own front ends with JavaScript using React.js, for example, Next.js, for example, and then you can also build specific algorithms, applications which actually solve software problems with like AI applications using Python, or data science, data pipelines, or machine learning applications using Python. So we're gonna deep dive into Python from beginner to intermediate level, right? So uh, yeah, so that is why I was talking about that these are the major programming languages. JavaScript is basically dominating the entire web and front end engineering right now, and Python is baked into most of the algorithms in the backend and automation space. So if you basically try to understand programming, then yes, the most important stuff is variables, because you would want to work with some data and then you would have to store that data into some containers. So that is a variable. So in JavaScript you can use let keyword to declare variable, or you can even use const to declare constants. And then Python, you don't need any prefix. You just need the variable name and then the assignment operator and the value that you want to put. So in JavaScript, if we uh, if we see the example, then we can copy by value for the primitives, and then in this case x becomes 10, y also becomes 10. But with objects the behavior can change. They would point to the same memory reference in the memory area, right? So now we have JavaScript has number, string, boolean, null, undefined, symbol, and bigint. Okay, so that is what JavaScript is. And in JavaScript, you can have number equal to 10, text equal to hello, flag equal to true, something like that. And what that does is it basically assigns values to the variables and stores them in the variables. In Python, you have built-in types like integer, float, string, boolean, list, tuple, dictionary, and set. So in Python also you can do the same thing. You can say number equal to 10, text equal to hello, flag equal to true. But the syntax is a bit different and a bit mature and bit verbose. I mean, not much verbose. It's like basically much more closer to natural language. Now the main important stuff that is in the fundamentals of programming is control flow. So I can say something like that. Okay, if my age is greater than 18, then I'm an adult. Otherwise, I'm a minor. So in my program, I can make decisions using that. Next is Python. In Python also you can also do the same thing, but in Python for indentation you don't create blocks. Notice how in JavaScript you have created curly braces blocks, but in Python you create indentation, and then from indentation you write uh, the basic the various statements. Okay, now you have loops. So for loops you can basically you don't want to repeat the statements that you put in the code, so you can put loops in there. So you have I equal to 0, I less than 5, I plus plus, console log I. Okay, and then in Python you can have for I in range 5 print I, right? Similar thing, but you don't have, your loop is much more concise. Next is functions. Function is a very important part of programming, and there's a whole area called functional programming, which is very useful if you go deep into programming. So like you can reuse functions again and again. You can basically have modules that export functions, and you can import functions from somewhere, and then you can reuse functions in multiple places using module pattern. So there are multiple ways to define functions in JavaScript. One is the named expression, or the named function declaration, and then there is there's a function expression declaration, and then there is arrow function declaration. So the arrow function declaration is something like this, in which you use the equal greater sign, and then you can even create a block if you want, but this is since it's a single line function, then it can return right away the value that it is returning. So basically function takes an input, does some processing, and gives an output. So functions can define the algorithms. So to do some algorithm, you can define the function that you need. Now data structures, so they are kind of crucial for DSA and real applications. We have numbers, we can push numbers, we can pop numbers, and then we can append numbers, and we can pop numbers, and then we have dictionaries to define different types of data, and then we have Python dictionaries which can define the different objects. Now we go into intermediate JavaScript. So in intermediate JavaScript, we have a concept of closures. Now what is a closure? Closure is a function in which it has an inner function that remembers variables from the outer function. Okay, so this count resides in the outer function, and it remembers this count value because it was declared in the outer, and the outer function is not dead, right? Because it is exposing this inner function to it. So you return that inner function, and then it maintains that state of this count, and this helps in data abstraction and data hiding, and also state management. Okay, so usually people develop closures. React hooks are built using closures, and private variables are also there, and functional programming is also something similar. Now we have event loop. Event loop, what is the use of event loop? So you can understand it like this: JavaScript has some web APIs to defer some execution, debound some execution, or because it is single threaded, but we cannot have softwares running taking a CPU core entirely and wasting resources in IO and everything. We can have asynchronous nature with JavaScript. So we can put console logs and then they run directly, but then if we put a set timeout, it basically goes into something called callback queue, which is also a name of macro task queue. What it does is it defers the execution of that state of that function, and then basically whatever is the statements lying inside it, and then it resumes when the single thread is idle, and then it picks up that sort of computation to do, right? So in this example, we can see that start gets printed first, and then end, and then timeout. Okay, and why does that happen? That happens because we have call stack, web APIs, callback queue, and event loop. So event loop is basically what the hell is event loop? Event loop is that for example, we click something on our desktop, right? An event happens, and then that event gets processed, taken by the JavaScript engine in the browser, and then it processes that event and then outputs the result of it, and that happens in an event loop fashion, and then it starts listening for other events. So it basically maintains queues or task queues to manage the events in the JavaScript. Now next concept is promise. Promise are microtasks. So microtasks are something that immediately resolve a value or reject a value, and then basically you can take that result and then you can do some processing after the result has been achieved. For example, it can be used for API calls, and async await can be used for asynchronous code. So if you make it is much cleaner abstraction over promises. So using async await, what you can do is you can await a fetch of a URL, get a response, get the awaited data, and then return that data. Now you have intermediate Python. Python is very simple and has powerful tools. One is list comprehension. So if you have a numbers list and you want to convert it using some mapping logic, then you can, for example, get the squares of those numbers by taking that comprehension feature and saying that, okay, I want for every element x into x where x was in nums, right? Then it becomes 14916. Now this is lambda functions. Lambda functions are anonymous functions, so you can assign the result of a lambda to a variable and then you can call that lambda function. So it is a, b and a plus b, right? Then this is a add function, then this becomes a lambda function. Iterators are basically objects which gives us the values sequentially. So you can iterators basically work using the iter keyword. What you do is you basically iterate over nums and then it returns an iterator, and when you print the next iterator it will return num1 here. Now there is another thing called generators. In generators you can say that okay, I can yield a value and then I can increment. So what will happen is you can basically take that function and the result of that function will return the values one by one to the calling context, right? And it will also continue executing in a loop. Next is file handling. So you can say with open file.txt r as file data equal to file.read. Now let's go into Node.js. In Node.js, we can have the fs module, and the fs module gives us the fs package, and it helps us to read a file, and then we can say that okay, this is the error or the data, and we can console log out that data. Next part in JavaScript is error handling. So you can use try catch to handle errors. So suppose your function does something, some complex calculation, and somewhere along the line it makes an error, right? That will generally crash the program. But if you use a try catch, the benefit is that you can handle that error so that the program doesn't crash and it gracefully exits out of that uh, whatever the whatever the result was there, that can be logged, the error can be logged, and we can read through the stack trace and figure out the root cause. Again, then there is a try except in Python, in which we can run a exception and then we can print out that exception. Next is object oriented programming. So in JavaScript you have classes, but they are not actually classes. So what they are actually basically working on the principle of prototypes behind the scenes. They are not actually object oriented classes, but you can use them similar to the normal classes, and you can define methods on them, and you can use the this keyword to access the properties of that object, like mutate or change the properties and then access the properties of that object. So similarly in the Python you can use indentation blocks and you can define function methods on it, and then for constructor method you have init, and then for any method that you define you provide the context, which is the self, similar to this, and then you can have that object hold that property with that, and you can reuse that property. So going forward, if you have got good grasps of JavaScript closure, prototyping, programming, event loop, DOM manipulation, and modules. Similarly, if you know a bit of generator, decorator modules, file handling in Python, then you have reached an intermediate level of developer, and that is a very good place to be in. So these concepts, if you practice, you will become a much stronger developer, and you can build truly anything, like starting from end to scratch. So data structures and algorithms, and then JavaScript and Python, and then if you want to go in deeper into web development, then you can go into front end, then you can go into React or Next.js. If you want to go into back end, you can go into Node.js or Express, and a little bit of you can understand databases like MySQL, MongoDB, PostgreSQL, or these tools and technologies, which will help you build systems from end to end from scratch. So these are the fundamental concepts that are going to be used throughout software engineering careers. Okay, this is the end of the video. Now we have reached the end of the video. I hope you like this video. Let's see what the audience thinks about such a video, and then maybe I'll make more videos in the future.